Hey guys, it's your boy. No, I'm just kidding. What's up, guys? So today we're going to be learning about the rational roots theorem, and as well, I'm going to go ahead and talk about multiplicity, since I know in the last video I didn't mention it. So multiplicity really isn't that bad, and neither is this rational roots theorem. And they're actually both pretty helpful, especially when you're sketching graphs and finding the real zeros. So let's go ahead and begin. To be honest with you, it's not that bad. So go ahead and pause the video right now and go ahead and try this little warm-up. And this is very similar to the homework that I made for you guys. And this pretty much tells us like, hey, what are some basic characteristics that we have? So pause the video and we'll go ahead and try this. So thanks. So hopefully you were able to try this, and honestly, these are just some little questions that they go ahead and ask, like what is the degree of this polynomial? So we can go ahead and see that every single exponent, whether it's this one to the 0, this one to the 1, 2, or 3, the degree is the biggest exponent, so the degree is 3. So that doesn't really mess people up that bad. And the leading coefficient is the term, I'm sorry, is the constant that is in front of that term with the highest degree. So in this case, the leading coefficient is a 5. Max amount of terms. So here's where my students tend to forget that your max term is determined by the degree minus 1. This will go ahead and tell you the max churning point. Max churning point. So horrible handwriting, but we go ahead and get our degree, which is 3 minus 1. Quick maths tell me that is 2. Okay, max amount of zeros, we can go ahead and see that the max amount of zeros is the same quantity as the degree. So max zeros is the same digit, is the same number as the degree. And we're going to go ahead and learn about that a little bit later on in the class. We're actually in 2 more lessons, and we can see that this is 3. And that's going to go ahead and tell us about our complex zeros, or our positive or negative zeros, or complex zeros. Okay, so according to this function, it is a cubic, right? Because our degree is 3, so it's going to behave like an x cubed, meaning if I was to go ahead and make a little xy grid, and I was to go ahead and draw the end behaviors of this graph, it would behave like a cubic, meaning the right side would go up and the left side would go down. So something like that. So like our ballerina dance, remember, like we have that right hand going up, left hand going down. Okay, so that's pretty much what we're saying. So ideally it will behave like this right here. And we can see that this right here, this one, where they're pointing down, that refers to our negative x squared. This one is our x squared. This is our similar to x cubed. And this is to our negative x cubed. Okay, so hopefully that didn't mess you up that bad. And if it didn't, way to go, guys. So you're on it already. Just looking a heads up. So yesterday was Labor Day, so we had that off. So don't worry about Monday. Today we had a tutoring 4:30 to 5. We had a couple show up. Today's notes are 2.2, and our lesson, our homework, is due on our notebook on Friday. 2.3, I'm gonna start putting the titles on these. It's also due on Friday. 2.4 is gonna be due on Tuesday, and on Friday we have a mid-unit quiz about chapter 2. Okay. All right, so let's go ahead and get started. First of all, what is the rational roots theorem? So pretty much it's a way to look at the polynomial and determine how many possibilities of zeros can we have. It says rational because some of the terms often provide fractions, but don't fear, remember, fractions are friends. Okay. All right, so go ahead and pause the video right here and write this down. This is going to be very, very helpful when we're talking about multiplicity, and it's going to help us sketch. So go ahead and pause the video right here and write these on your notebook. Okay, alrighty, so hopefully you were able to write this down, and we can go ahead and see that if I am given a polynomial that is in factored form, we can probably see that the polynomial will probably be something like that, and it'll be in factored form, and it'll give you a whole bunch of little parentheses, right? Those parentheses will have exponents, okay? So if the factored form has the function that is factored has an exponent that is even, that means that it's going to go ahead and touch at whatever that c value is. And in order to find that C value, you just get what's inside the parentheses, you set it equal to 0, and whatever that number is, that's where it's going to go ahead and touch. That's going to be your X value where it's going to touch. Same goes for the odd. So you get your function in factored form, and if you go ahead and solve for the inside, it's going to go ahead and give you a C value. Okay, so you set it equal to 0. It's really not that bad, but what I want you to know is that if it's even, it touches, meaning just like freeze tag, you go ahead and touch someone and you bounce back, right? You don't just wait there, you just bounce back. And if it's odd, it just crosses the x-axis. So it sounds scary, it really isn't. Let's go ahead and try some. So what I want you to do first is identify what the parent function is. So that's what intimidates a lot of students, but what you need to know is that this right here, we're just thinking about the parent function, right? So right here I got x squared, right? So x squared. And this right here is x cubed. So ideally these are being multiplied together. So I got x squared and x to the fifth. I'm going to go ahead and show you how it works by multiplication. So this is ideally x squared is x times x, and x cubed is pretty much x times x times x, right? Just in case we don't remember how to multiply these terms. So it's the same thing as saying x to the 1, 2, 3, 4, 5, so x to the fifth. So just in case you don't remember how to multiply terms with the same base, you add the exponents. Pretty much you can write it out using the same thing. But hopefully you start remembering that this right here is how you multiply terms with the same base. So what am I trying to say here? Well, the parent function is x to the fifth, meaning that x to the fifth looks like an odd function, so it's going to look like a little ballerina dancer, right? Little left hand down, right hand up. Okay, so I'm going to go ahead and draw that. I'm going to say my right hand like this up, and my left hand is down. So this is the end behavior. So no matter what my function does, it's going to go ahead and end up this way. Alrighty, so let's go ahead and do the following, which means that we're going to go ahead and get each one of these little parentheses. So I got x minus 2, and I got this other one, x minus 4. So what we're going to go ahead and do is we're going to go ahead and set each one equal to 0. So let's go ahead and set that equal to 0. So each individual term, right, inside the parentheses equal to 0. So I got this one right here, x minus 2 equals to 0. Add 2, x is equal to 2. So at x equals 2, I got, right, at x equals 2, I got an x-intercept. The next one is x minus 4, and I got it from my factored form. So set it equal to 0, x is equal to 4, so x is equal to 4. So I got something like so right here, x equal 4. All right, so we're almost done. So right here, we're going to go ahead and see. I'm going to go ahead and hide everything. Okay, so I'm going to go ahead and hide that so you guys can see. I have the same little chart from the other notes. And we're going to go ahead and look at the exponent of each individual factored form, right? So where x equals 2, my multiplicity was an exponent 2. So my multiplicity is 2, meaning it is even. So when it is even, it touches. Okay? When x equals 4, my degree, my exponent was a 3. So my multiplicity is 3. That is odd. So it crosses. And if you guys don't remember from the last slide, we saw that if it's odd, it crosses the x-axis, and if it's even, it touches the x-axis. Okay, so we always start from the left. So according to this, it is below right here. It is below, so I'm going to go ahead and get a different marker. So it is below right here. So it's going to go ahead and go to my x equals 2. And I'm going to start brainstorming because it told me that it touches. So it's below, so it's going to go ahead and go right here. It's going to touch it, and it's going to bounce back, right? It's going to touch the x-axis, it's going to bounce back. It doesn't have to be pretty, guys, but it's just pretty much that it touches, right? It doesn't cross. The x equals 3, when x equals 4, it's odd. So therefore it's gonna cross. So the only way it's gonna cross the x-axis is if it curves back up. So it's gonna cross, and notice how it landed back on this end behavior, right? The arrow pointing up, the arrow pointing down. So we did pretty good. Okay, so just to stamp this down, this was x minus 2, and it was to the second, so it was even, so that's why it touches. This right here was x minus 4 to the third. It was odd, right? The exponent was odd, so it crossed at x equals 4. So honestly, these aren't that bad. And this pretty much gives you a way of finding a sketch and find the multiplicity. So that's what the multiplicity means. Okay, so go ahead and pause the video and give this one a try. Cool. Alrighty, so we're gonna go ahead and do the same thing. First of all, find the parent function. How will this behave? So I got an x to the first and x to the second, x to the first and x to the second, right? I don't really care about that minus 3 yet. So my parent function is gonna be x to the cubed. Ooh, nice for us. Looks like that same ballerina dancer. So meaning our end behavior, the right's gonna be pointing up, and my left is gonna be pointing down because it's gonna behave like a cubic function. Okay, so let's go ahead and try the next one. I'm sorry, this one right here. I'm gonna go ahead and find the x-intercepts. Where are my x-intercepts? So I'm gonna get these parentheses, so it's x plus, wait, I don't see anything. So it must be x plus 0 equals 0. So x equals 0 is my first point. And x minus 3, I said that equal to 0. So x equals 3 is my other point. Okay, so I got these two locations, x equals 0 and x equals 3, because I set the factor form equal to 0. Okay, now all I have to do is find out, does it cross or does it touch? So we're gonna look for the multiplicity. So in this multiplicity, I look at the exponent, and if the exponent is odd, right? In this case, for my just my x, the exponent was a 1. If you don't see anything, it's a 1. The multiplicity was 1. That is odd, so therefore it crosses. So it crosses at x equals 0, right? Because that was where I found the x-intercept. So I'm gonna go ahead and see my graph. I'm gonna go like this, like this, like this. And once I get to x equals 0, I'm gonna go ahead and cross, right? Alrighty, so the next one says x minus 3, right? To the squared. So I'm gonna go ahead and find out what is my multiplicity. So I found out my x-intercept is x equals 3. My exponent is a 2. So my multiplicity, because my even exponent is going to be even, so it's going to touch. So it's going to touch. So you're going to have to see that this graph is probably going to have to come back down. It's going to go ahead and touch and come back up to meet that requirement of the end behavior. Alrighty, so we're going to go ahead and snap those points down. So remember, x equals 0. This came from just the x, right? From this right here. It was an odd, so it crossed. This right here, x equals 3, came from x minus 3 squared. The exponent was even, so therefore it touched. Okay, so overall they're not that bad, guys, and the end behavior we found from the parent function, from the degree. The degree will always tell you how these arrows are behaving. Okay, go ahead and try this video. Go ahead and try this problem. So go ahead and pause it, and hopefully, just kidding, it seems I duplicated it. Not to worry. All right, so go ahead and try this one out and find out which one of these graphs is a possibility for this function right here. So go ahead and pause the video. Awesome. So same thing goes. I find the power function, the parent function. So I got x to the third and x to the second. If I multiply that, I get x to the fifth. So I should have something like so, right? meaning my end behavior should be the left-hand side pointing down, the right-hand side pointing up. So by process of elimination, I can see that A is not it because both of these end behaviors are pointing up. So A is not it, sorry. But this one, my B, is already pointing down on the left and pointing up on the right. So same goes for C. So B and C are an option. The next thing we want to go ahead and do is find out the x-intercepts. So if I get each individual parentheses, x minus 2, I set it equal to 0, I get that x equals 2 is a value. It's going to be an x-intercept. So x equals 2 right here and right here works. Okay. My exponent, oops, sorry, I covered it, but it was a 3. The 3 is odd, so it's going to cross. So you can see that it crossed on both of them. Ooh, tricky question, right? Let's go ahead and do the next part, x minus 1. So I'm going to go right over here, x plus 1, sorry, x plus 1 squared. I get that my x equals negative 1. The exponent is even, so it's going to go ahead and touch. So we're going to go ahead and see that at x equals negative 1, it's going to go ahead and touch. It's going to behave like a parabola. And we can see that both of them behave like a parabola, but the only one that has x equals 1 is B. So be very careful. It pretty much flips the sign, as my students were saying, but it's up to you if you see it like that. I just solve for 0 and you can pretty much see it, but if flipping the sign works for you, that is perfect. Alrighty, the rational zero theorem. So what I want you to know is that you're probably going to get a polynomial and you want to find out, well, how many possible zeros do I have? And it's honestly not that bad to go ahead and figure that out. Pretty much you look at the factors of the ending term, which is right here, the P, and the factors of the leading term, which is my Q. Okay. And then once you have the factors, you go ahead and divide each factor of P, you divide it by your factor of Q. So go ahead and pause the video, write down these notes, and you're gonna go ahead and see that it's not that bad to find these. Okay, so the same thing goes. We're gonna go ahead and see that the value at the end is the P, and the value at the beginning, your leading, is gonna be your Q. Okay, so know that you're gonna go ahead and find the factors, guys. I know a lot of students just want to divide and say, oh, it's probably 1/4, but what I need you to know is that you break it up into factors. So you get the factors of P, which we just said is 1, and the factors of Q, which is 4, and you factor it out. So what times what gives me a 1? Well, it's prime, so it's only 1. What times what gives me a 4? So 1 times 4 and 2 times 2. And you go ahead and write out the possible zeros by putting the P's divided by the Q's. So I know I pretty much summarized it, but that really helps just to visualize it before we jump in. So let's go ahead and do one. My P, right? My P comes from the end. And notice that I don't really care about the negatives or positive, because at the end of the day, you're going to consider both terms, positive and negative. Okay, so my P is from the end and my Q is from the beginning. So my P is 3 and my 2 is my Q. So keep in mind, I didn't carry the negative, because at the end of the day, we're going to have this right here, this little symbol that means both positive and negative. So let's go ahead and find the terms. So what numbers multiply to 3? So 3 is prime. So that's the same thing as saying 1 times 3. So it's just 1 and 3, right? The next one is 2. So what times what gives me 2? So also 1 times 2. So you should have 1 and 2 only, right? Because both of these are prime. So these are the factors of P and Q. So once you have these factors, you go ahead and put them into a little fraction, so plus minus, and you're going to go ahead and get all the P values, which is 1 and 3, and you're going to divide them by each of the Q's. Each of the Q's, guys. So I'm going to go ahead and write them once. So 1 and 3 divided by my first Q, which is 1, honestly stays the same. And the next one says that it's 1 and 3 again, right? Divided by my second Q, which is 2. So 1 divided by 2. and 3 divided by 2. Sorry about that. So this is what I want you to know. These are all the possible zeros. Now, what I like to stamp is this right here, plus and minus, meaning this 1, this 3, this 1/2, this 3/2. Those are all for the positive and negative, meaning you have 1, 2, 3, 4, 4 positive and 4 negative. In total, you have 8 possible zeros. Okay. All right, let's go ahead and try the next one. Let's go ahead and try this one. Go ahead and pause the video and try this one on your own. Okay. So hopefully you were able to try it. Same thing goes. You get your P, you get your Q, you get the factors of each of them. So my P was 1 and my Q was 10, and I get the factors of them. So what times what gives me 1? Well, that's only 1. What times what gives me 10? So that's 1 times 10, right? 1 times 10. What is another? What other numbers multiply to 10? So 2 and 5. So we have 1, 2, 5, and 10 that multiply to 10. Those are all factors. And this is our P. This is our Q. And last but not least, all we have to do now is we're going to go ahead and put our P's divided by each of our Q's, okay? So I'm going to go ahead and put the plus minus. Okay, so I have 1 divided by 1, 1 divided by 2, right? And we do it for each of our Q's. So 1 divided by 5, and hopefully you were able to see the last one's going to be 1 divided by 10. Alrighty. So just to stamp this down, how many possible zeros are there? Okay. So remember, there is 1, 2, 3, 4, 4 positive and 4 negative. So in total, we have 8 possible zeros, right? So pretty much, guys, this is what I want you to see, is that you're able to find different possibilities. But according to what we will learn later is that there's only 2 real ones, but there's 8 possible. Okay. All right. So go ahead and try this one on your own. This one's going to have a lot more zeros because, as we can see, both of these are not prime numbers. This is 6, this is 4. And when you go ahead and factor them out, oops, I put a negative, but that doesn't matter. When you factor this out, you can go ahead and see that there is way more values, right? Okay. So you do the same thing, but notice how you're going to divide it by each of them. So go ahead and pause the video and try this on your own, and then I will go ahead and show you the solution. So the first one wasn't that bad. Everything divided by 1 is the same thing. So 1, 2, 3, and 6, not that bad. How about everything divided by 2? Everything divided by 2, that means 1 divided by 2, that's 1/2. 2 divided by 2, that's the same thing as 1, right? So I wouldn't really write it, but I'm going to write it since some of us might not see it. And 2 divided by 3, that's 3/2. And 6 divided by 2, that is 3. So this is 3 and this is 1. So friendly reminder, you don't have to write those repeating terms. It's just going to throw off your numbers. Okay, let's go ahead and try the next one. 4. So everything divided by 4. So 1 divided by 4. Then I have 2 divided by 4. Keep in mind that's the same thing as 1/2. 3 divided by 4. And that's 6 divided by 4, which is what, 3/2? Yes, no? Okay. So we can go ahead and simplify this because I don't want any repeating terms like 1, like 3, like 1/2, and like 3/2. So in reality, our answer should be positive, negative, right? We want both positives and negatives. So 1, 2, 3, 6, 1/2, 3/2, because I'm not counting these, because I've already accounted for them. 1/4, 3/4. Okay, so for this example, we have 1, 2, 3, 4, 5, 6, 7, 8 positive, 8 positive, and 8 negative. So we have a total of 16 possibilities, zeros. So keep in mind, this right here counts for both positives and negatives. I can't stress that enough. And I'll show you guys how to determine which ones are indeed the real zeros. But this is how we find all possibilities. Okay, so the homework is already delivered to your notebook, and that is 2.2. And friendly reminder, all you have to do is type the solution, unless you are going to go ahead and upload an image, which I'll gladly accept as well. Okay, alrighty, and the exit ticket is on your Google Forms, and that is under the assignment. So go ahead and state all the possible zeros. Okay, alrighty, guys. If you do have questions, make sure you reach out to me. If not, awesome. Thank you. Later, guys.